what is the
let him
angular,
see if he can work it out.
What is the angular speed of the moon? How do you get the angular speed of the sun?
Just give me a second. Keep talking. I'll
No,
get
just
those
tell me
results to you in just a second.
How do you get the angular speed of the sun? Tell me how you do that.
He has no idea.
You would measure your position. You would look at the sun's position in the sky based on yours, and you would measure the difference. Like, how is that? That's not hard.
No,
David.
how do you actually measure the angular speed of the sun?
What I just said, you would do that, and then you would look at it over time.
It's the rate that it covers its own width in time, right? So if it takes 2.5 minutes for it to cover its own width, that's the angular speed of the sun, right? Which is 15 degrees an hour.
Okay, all right. Now you figured it out. Okay, so why are you asking?
Okay, that's not the way they do the moon. Why?
How did they do the moon?
No.
Well, that's because you guys are true believers. Why don't you go true believe some more shit that you don't know nothing about? Thank you very much.
Monkey Sage?
Okay, so it's the moon rotates at 0.055 times.
We're not talking about rotation. You need to go back to like what, 10th grade or something, and tell your science teacher that they've been brainwashed by communist superiors, and they need to start thinking for themselves and quit teaching just out of the damn book and try to teach people logical thinking. Okay,
we can do that. But
I'm just trying to explain to you that what you just said, you're full of fucking shit, is what I'm just trying to say. But you can't handle you can't handle the truth.
Yet somehow you don't know the answer, Jazza.
Well, I was just trying to give it to you,
just
so I'll
worked
go and
it
have a
out,
smoke and let you cool down. Oh, I just.
What's the answer, Jazza?
No. You guys cool down. I've got the answer right here. I'm going to go and have a smoke. I'll come back and we'll talk about it. You guys discuss how you're going to make shit up to not take it as evidence.
Don't have evidence.
You got it wrong, Jazz.
I'm having a smoke. I'll be back in a minute. I will revise and...
You better check your work while you're out there.
I will do that.
You did it wrong.
It's even less than what I just said, to be honest.
Do you even know what the question is?
How much does the moon rotate in 27.8 days that it goes around the Earth divided by a month? Divided by the days, divided by 24 times those days, will give us an hourly rate that the moon rotates. By degrees.
You go ahead. You go, Jazzy. You got this. You the man.
No, I'm having a smoke. You go for it.
Always the way, Jazza. Always the way. Always tomorrow. Always later. That carrot on the stick. Yes?
Yeah, well, I think you're just making up stuff, Chemo. You don't
Always
even...
the true believer, always the one that just believes it because the math says it so, because the scientist says it so, because Joe Biden says it so. That's the reason why, isn't it?
Because Joe Biden said it, of course.
That was a good one.
Chemo, I
Because
think
Joe
you're
Biden
just...
says so.
I think you're just making up stuff. Like,
It always
you
seems
honestly...
like that. But
yeah, I always think like that. Yeah,
it always
that's true.
seems like that. Yes, I understand.
Yes, it seems like he's making
That's
stuff
because
up.
we're
But
going against
actually,
the entire
Chemo
establishment.
Chemo is not making stuff up. He's just regurgitating bullshit on the Flat Earth Discord.
No, we're going against the entire scientific establishment.
Can you make something up, Chemo? Original ones? I mean, you already did that there is no pressure gradient. That was original. Have
The
you said
rainbow.
anything else besides that?
No, Chemo came up with the rainbow. You can't make a rainbow
That's
with
been
the garden
debunked.
hose.
That's been
Oh,
debunked.
yeah. Yeah.
Debunked. Can make a rainbow.
What do you mean?
Been practically demonstrated.
Just trying to give you credit, because, you know.
Oh, right, yeah. Yeah, but you can make a rainbow.
So can you make something up?
Space is an expanding universe.
I didn't think so.
That's a good one. How would we prove that space is an expanding universe?
No, that's a general idea. Big Bang tells them so.
And at a certain point in time, you would expect to look at space and see a certain energy distribution, right? So if we did look at space and we saw that, we would say, oh, I guess that's true.
Yeah.
If we're going to go somewhere, why can't we go like to the New America, you know, past the ice wall or something? I mean, get a good story going. Let's something to look forward to, you know? I mean, why go into somewhere where there's nothing living? I mean, Jesus Christ.
That's because those things are fantasies, David. You can't go to Narnia.
Narnia is what we call space, the place that doesn't exist.
I know you call space Narnia, Kim. That's retarded.
Well, how can you go to an area that is vacuous next to a high area of gas? Come on, dude.
Ask the astronauts.
Yeah. We've asked the aquanauts, as they're called, aqua. Yeah, they go underwater.
I believe you got your dictionary wrong.
Are we just going to let them slide on this, really? I mean, if we're going to go all hard on them, let's go all out. Where is the high pressure next to vacuum, Kima?
High pressure next to it. So your space.
I have it. You don't have it.
Yeah, space has no pressure because it has no container.
Listen to him struggle. He doesn't know what to say.
No. In space, there is no pressure because there was no wall,
Not much.
there is no like mass to attract the gas, even if there was in space.
Do you think that's consistent with gravity at least? I mean, not assuming it's true, but do you think that?
Oh, we have a debate now.
One sec. If gravity works the way we say it
Get
does,
busy now,
would you
guys.
say? One sec. Let me just finish the question. If gravity works the way we say it does, would you think that's consistent at least with a pressurized atmosphere in the vacuum?
Of course. If the Earth was a giant mass, really strong milkshake.
You cut out for some seconds. Can you
Yeah, I was
repeat
about to
that?
cough my guts up. But if the Earth was a mass in space, then the theory of Newton's gravity is a good idea until Einstein comes along and says, well, no. Because you've got to understand, the idea is that why they came up, because if the Earth, say like if the Earth's bending the fabric and it's connected to the moon in some way with that gravity pull, if you just pulled the Earth out of the way, they said this force wouldn't give you the right results. It doesn't work in space, the universe, basically. Newtonian
What
gravity.
on earth are you rambling
Yeah,
about?
but
There is the vacuum next to the high pressure.
Alright, back to the vacuum. Yeah, so I'm saying that if gravity was a thing, yes, it would pull the atmosphere down, but we know it's not a force, Bacon. So, space has no container, space has no force. So there is no...
Oh, 1 second.
What?
One second. Claiming it's not a force. It's just a different description of like the fundamental nature of gravity. But both models, the relativistic model and Newtonian's model of physics, they both make very, very close predictions. So even if you might claim it's not a force and then under relativity, It wouldn't change anything about.
Sorry.
1 sec.
No, hold on. Let me. No. Look, even if you have gravity pulling the atmosphere, space still has no pressure.
And so?
Okay, so you've got this high pressure next to low pressure, right? We agree on that.
Where?
Right. No,
that's what
You keep saying that, but you can't show it.
But
We
I don't think you get the model.
Let's help Curve because he's struggling with this concept.
No, first you said it was coherent. Now you're claiming it wouldn't be consistent with
No,
the.
I'm saying yes. If Earth was a ball in space and Newtonian gravity was pulling the atmosphere, you have in space no pulling of anything. No forces are in space, right? Huh?
Well, actually, they are, but
What forces?
well, the same ones. They're just weaker because they're further,
Like what?
like gravity.
Gravity's in space.
Yeah, everywhere.
Right, it's when you got a large mass, right?
Well, when you get further from the large mass, the force decreases. It never goes away. It just decreases.
Yeah, it has a field. A field. And once you're out of that field, you're no longer being affected by the Earth's gravitational pull.
Why wouldn't it be another gas out there is what I don't understand. If the Earth is covered up in all these gases, why wouldn't it be another type of gas out in space that's even lighter?
Like Jupiter, like Saturn,
Yeah,
like
but even if there
Uranus,
was
like
gas in space,
the sun.
there's still no pressure in space. Even if the
Yep,
gas was there,
exactly.
where would the
Right.
pressure come from?
Yeah, if you throw gas on the space, of course there's he will be far. It will be far from planets. You wouldn't get a ball of gas on that would be able to contain itself on its own weight. If you have enough gas for that to happen, then you have a gas giant, for example, or a star, because it's so much mass. Then it's the gas alone is enough to contain itself on its own weight.
No, but that's what I'm saying.
So it's a matter of scale. When you guys ask, like, can you give me an example of air, like a smaller scale example of air pressure without a container, you're basically asking for a small scale of something that is supposed to happen only in huge scales. So that's already doesn't make sense to happen.
I'm agreeing with you about if there was gravity hold the atmosphere, right?
Yeah, and you agree that gravity has mass, right?
Gravity has mass.
I mean, not gravity. Sorry, the atmosphere has mass, right?
No, the atmosphere has no weight.
So how did you
Derive this.
Yeah.
Yes, because the weight come from the container.
It's just a recreational diversion to keep from discussing the actual question. Where do we have high pressure next to the vacuum? We don't. Argument dead.
Talking about space has no pressure.
I know this isn't as much fun, is it? But you're wrong.
We say it slowly. Space has no pressure. There is no force or container to accumulate pressure. That's
right. Space is just there with no pressure.
There's no pressure. You say there is atmospheric pressure.
All right. Let's replace. Let's think of an easier example then. Let's suppose we have a planet that only has water, right? It's entirely covered in water. Would you see that we would have different pressures in the water as close as you get to the solid surface? You have a higher and higher pressure, right? And in the very surface of the water, you have the lowest pressure, right?
Okay.
Would you see that happening? You understand that's what would happen under
Underwater.
our model, right?
Underwater.
Yeah.
Underwater.
So the exact same thing is what happens.
No. The water.
One sec. Under our model, air does have weight, right? As the air does have mass. Same thing you would expect the same thing to happen with air.
No, again, these expectations, you know with them. don't have the science to
How
back it
about
up.
No,
how
air
about
actually does.
how about a rock? How about a rock on the bottom of the ocean? Do you think a rock on the bottom of the ocean has more pressure on it than a rock that's sitting on the shore?
That's it
Of
on
course
what?
it does. Of course it does.
Yeah,
Has
that's
more
actually
pressure?
very measurable. That's very measurable.
So you think a rock sitting on the bottom of the ocean is under pressure because the water's sitting on, because it's sitting in water?
Yeah. All that
Well,
water
because
is
of the
sitting on
weight of
top
the
of
water.
it. What,
Yeah,
what
I
are
mean,
you talking about, David?
people can experience that. Actually, it's not that restricted. Anyone can do it.
Remove the walls of that water container. The water will find its level. Then what?
All right, but I was giving the example of a planet entirely covered in water, right? You
I'm
understand that the
saying
same thing
the
would
pressure
happen under
comes
gravity,
from-
right?
Pressure comes from the walls of the.
No, it doesn't.
No.
Because yeah, I think you're failing to understand the model. Then
No, I know your model. You say there's a force, but I'm saying that the pressure comes from a container.
well, so you're okay. One second. One thing is to give an alternate explanation.
Oh,
The
let me
other
ask you this quick before. So when a raindrop is falling, is that raindrop under pressure? Measure
Yes.
What pressure is it?
the atmospheric pressure.
No, the raindrop.
Yeah, it's under the atmospheric pressure.
The water. How much
Exactly.
water pressure is?
Inside the drop?
Can you measure that as it's falling? Can you measure the pressure?
Not until
Yeah.
it hits the ground.
Not until it hits
What
the
the fuck are you
ground, right?
talking
So
about, dude?
It's surface. Yeah.
Flubba lubba lub.
So while it's falling, it has no pressure. Hits the surface, you can pressure. Yeah, you use surface.
Because,
So the water
because
is in a container.
as it's falling to the ground, chemo, it's weightless.
Exactly. Thank you. See, weightless. No,
No,
weight.
no.
You cannot weigh it. Very good, Jazza.
No.
First
For
thing you
an
said
observer
today.
who is falling with this,
No.
you would
said it
experience
has
no
weight.
no.
Weightless.
Oh, shut the fuck up.
Yeah, that's not. That's just the weightless thing is just from a perspective of an observer who is falling with the drop.
Just like a
No,
skydiver
it cannot
falling out
be
of the sky,
weighed
chemo.
unless there is a surface.
Yeah,
You don't know what you're
when
up.
you're in free fall, you don't
The water
experience
itself
weight
has no
because.
pressure.
Sorry,
The water itself, without the container, has no pressure.
it does.
Jazza, your
It's-
Kiwi
it's the
physics
same as
are bringing
atmospheric
shame
one.
and disrepute to the globe, Jazza.
No, Jazz is on point here. Malone. Well done,
It's not
Jazza.
my fault you don't understand it, man.
Jazza's wrong,
Chemo
Good
doesn't
Jazza,
either.
good
as
Jazza.
usual.
Oh, okay. Let me. You know the pressure is like force over area, right?
Yeah.
Chemo. Okay, so if I put a drop of water over a surface, the drop of water has a weight, right?
No, where did the force come from? What is
No,
the
I'm
force?
asking if.
It
I'm
has a
asking
weight, is what he's asking.
Yeah, it has a weight, right?
Yeah, because what are you saying that you drop the water?
I'm just saying I have a drop of water on the surface, right?
Okay.
And the drop has weight, and it's touching a certain area, right?
Yeah,
So there's a
around the
tiny
surface
pressure
level.
there.
Hmm?
So there's a tiny pressure there, right?
Yeah, from the surface.
Exactly. So if I
Around the
cover
surface,
the one sec. If I cover a full surface with many droplets, I will have the same pressure, but over the full surface, right?
Okay, what's your point?
Okay, so now if I put bigger water drops, I will have a higher pressure because they weight more than the small ones, right? So the bigger are the droplets, the greater the pressure is going to be. And if I keep adding droplets, I'm just going to basically feel something, and at any distance of the surface, I have a smaller and smaller pressure because there is less and less water drops above it, creating that pressure.
I still don't get your point.
Yeah, so the walls are just useful for the water not to fall from the surface. But they are not necessary because if I put a single drop and it doesn't spread, it still creates pressure. Saying that we require a wall, I think it doesn't make any sense. Of course, the wall is useful to create pressure because if you don't have walls, the water just fall from the surfaces. But the wall isn't what creates the pressure. What creates the pressure is the weight and the surface, and you know that.
Where does the weight come from?
That's a different question. We both agree it has weight, right? So we both would agree that the droplet creates pressure.
Only because of
So
the
we both
surface.
would agree that the walls are not required. The walls are irrelevant. They're just useful for the drops not to fall from the surface.
Yeah, this is water pressure. You need surface. Gas pressure. You need walls.
No, but what creates the pressure is the weight over an area, right?
No,
So if you have a mass,
surface is pressure.
no, it's the droplet. And not in where I doesn't have a droplet. I don't have that pressure.
Without the surface, we have pressure.
How is that related to what I just explained?
That's where the pressure comes from.
I think I made myself clear right now.
Yeah, but I've just said if that's the cause of your pressure, weight, or anything else, all I have to do is remove my cause, which is the surface, and now you have no effect.
Bacon, can I just say one thing real quick before I put my head through a double glazed window, listening to this fucking stupidity coming from this man, not from you?
Just a second, John. But Bacon, you understand, if I remove this variable, cause of effect, you're saying I'm getting this pressure because of the weight of the water. I'm saying if you remove that surface, there will be no weight.
Which surface? The one that I'm putting the droplet at?
Yeah,
What do you mean there would be no weight?
weightless. Without the surface, weightless.
Oh,
No.
No? How are you going to weigh it then without the surface?
Oh, I need the surface just to. I mean, if I hang something on a rubber, for example, I can measure its weight. It doesn't have to be touching the surface. The surface isn't what creates the weight.
Water.
Of course, we usually use surfaces to measure weight because it's easier. It's just a matter of.
How are you going to measure the water then without a surface?
Well, that might not be very doable, but that doesn't mean the surface is creating the weight. It's
How do you
just
know?
the easiest way to measure it
How do you know?
because it still falls.
So without the surface, you can still weigh the water.
Yeah, measure it without the thing on there, and then measure it with the thing on there. That's how we usually do that.
Well, how are you going to measure it without a surface on the water?
We call it a tear. You tear that out, and then you measure it once it's
Is that
going
right,
on
Bacon?
there. Yeah.
Sorry,
What Monkey Sage said, is that right?
I'm not sure what he said actually.
Alright, so how are we going to weigh the water without the surface?
soon Kimo's gonna say that the measuring device is the cause.
Of course.
What
Got it,
happens?
guys, without the
Yeah,
surface, trapped and stuck in quicksand.
Oh, I don't think you're being honest there.
I don't
Well, I
think
mean,
you're being honest either.
Yeah, because
Well, we started
me-
off with gas, and you went to
No,
water.
no.
So why
no,
did
no,
you
no.
go to
The
water?
questions you're asking are clearly they clearly don't add anything to the. They clearly don't affect the explanation that I gave.
They don't help your position. is
You're
what you're
on-
looking
We're
for.
playing lava now.
You're just asking for us to do things that are undoable. That's all.
I'm saying that we both agree if the water is falling, it's weightless.
No.
No, nobody agreed to that.
Yeah, it's only weightless
Accelerating down.
to an observer that is falling with it.
No, I'm saying the water falling in any situation is weightless. Unless that's, how are you going to weigh
No,
it
no, no,
without-
hang on,
Nobody
hang on,
agreed to that.
hang on,
You dumbass.
hang on. No, I did say that it was weightless, but the effect of the mass of water moving to the earth, the effect on it is weightless, but it is falling to the earth because it has a weight and mass. It's not
Jazza,
science
you're going to
and
need to lay the 100 elephants on them, Jazza.
I've been wanting to do that all night.
Go ahead, do it. Bacon needs to understand this.
Jason, you need a roll of an elephant, man.
No,
Hey,
bacon-
But look, let's get
Pass
back to
it.
the gas. We weren't talking about water. We We were talking about the
They
gas.
can understand that chemo, if I put 6 elephants on your big toe, on your right big toe, do you feel the pressure?
Depends on the medium I'm in.
You're in the air.
It doesn't matter what medium you're in.
Yes,
Sorry.
it does.
No.
Okay, so does the elephant right at the top, the 6th elephant, does he feel the weight of all that weight on your big toe on his shoulder?
In another medium, it would have no weight.
No, that's where space is.
Another
Fuck.
medium. Another medium. Yes, that's right. Another medium would have no weight. That's correct.
Nope. Sorry. Your medium
Holy
bullshit is bullshit, chemo.
Holy fuck!
Baz is
nuggets.
definitely on site today, saying some very good points. Another medium like space. That's one other medium.
We live in another medium. We live in
I'm
the
just going
atmosphere.
out.
We can think of other
I'm
mediums.
just going out. I'm just going out. Try
this medium
outside
thing
to
is
try
the
and not
latest.
kill myself. Jesus.
It's the
fucking
latest
Christ.
blurf bullshit.
Don't take the gun out with you. Leave it in the house.
Explain to us space as a medium, Kimo.
Just how would you weigh the Earth?
Kimo, you said because space is a medium.
The Earth has
Yeah.
no surface for you to
You
weigh
said
it. How are you going to
you
weigh
said
it?
space is a medium, chemo.
Yes.
How would you weigh space?
Chemo. With that question, you just made me go 3 levels higher. You fucking
Go on,
asshole.
how do you weigh the Earth then? How much does the Earth weigh?
Oh,
The
now
Earth
I'm up
has
to
no
21
surface
levels.
for you to weigh it on, so how are you going to weigh the Earth?
now I'm up 21 stories, so I'm definitely going to get the job done now.
How would you weigh space, chemo? Like, how would you weigh something, Earth?
In a
Something, space.
container, duh, you just said
Well,
it.
yeah. Okay.
container.
How would you weigh it
In a
independently?
container.
What's the
Well,
density
you
of
keep
space,
saying
Kimo?
that, but what is?
What's the
Yeah.
density
How do
of
you weigh
space?
it?
I mean, how? I've just told you I would get the pressure off the walls, and I have a gauge to how much pressure is and calculate how much weight is in there. Depending on the size of the container.
How would you measure the size?
Oh my god. With a ruler.
Kimo,
Hmm.
Kimo, yesterday, I think it was, you said that you have a vacuum chamber in your table. Do you think that we can have vacuum chambers on Earth?
Yeah, I mean, vacuums are not natural, no, so no.
Sure, but we can have a vacuum chamber on Earth, right? Like Biodual has.
Negative. Have low pressure chamber.
Yes, okay, low pressure chamber. What happens if you open that chamber when there is low pressure in it?
High pressure goes to low pressure.
Okay, so you have high pressure in the atmosphere now by your admission.
No.
We have air pressure. Well, where do you get the high pressure?
Oh yes,
Going
okay,
into
yeah,
that
okay,
low
fine,
pressure.
because we're in a container.
Okay, so now you're presupposing that we're contained, and you know that we have air pressure, right?
If you're asking where did the pressure come from, container.
Okay, so you now think that there is air pressure outside that vacuum chamber because high pressure moves to low pressure.
Well, it would be temperature.
So temperature moves to low pressure.
No, high temperature to low temperature.
No, but have you measured the temperature of the vacuum chamber? It's the
Yeah.
same temperature as the
Action
outside.
Lab has done that, yeah.
Okay, what was the temperature?
Drops.
It
It
dropped.
has to be lower. It's the only temperature that goes up before it can come down. There you go.
Removing the warm air from the box. How's it gonna increase it?
There is still air inside the box.
What about the radiations?
It's funny how dishonest you are. First you said, yeah, high pressure moves to low pressure.
Yeah,
Now it's
you
fucking
almost got me
temperature
then,
moving to
Martin.
temperature.
He's right though.
Yes,
Yeah,
yes.
he's right in that way. But first he says high pressure moves to low pressure.
Yeah, because
Then when I
can't
asked,
That was
say
to get
high
you
pressure
to
outside
understand
vacuum.
it. That was to get you to understand it, whether you knew it was right or not.
No,
Don't you listen
almost,
to it?
He doesn't
Martin,
answer my
very
question.
good. Because
No, he
yes,
doesn't.
you're saying that
Yeah,
there
he
was
said-
pressure outside, and where would that pressure come from? But that would come from a container.
I don't know where it comes from, but there is pressure outside the vacuum chamber, right? You agree?
No.
No. So high pressure doesn't move to low pressure then, in the vacuum chamber.
What do you mean?
That's on the medium.
Why do you need to have a vacuum chamber?
It's just low temperature.
So not pressure then.
It's high pressure.
And pressure, it's in a container, yes.
Okay. So what happens when you open the box?
It will just equalize.
Equalization! Yay!
Yeah, the pressure would equalize.
How can I have...
Follow the temperature.
Well, what, you're going to close the container again?
Well, this is funny.
Well, deep hole with water in it.
This is so funny. High pressure moves to low pressure. No. Actually, it's high temperature moving to low temperature. Where do you get the pressure from?
Yes, inside the container, because you're saying things, I have to think about what I'm saying here. So, inside the container...
Yeah, you have to think what you lie this time.
No, we have to think
No,
about
don't do that. You'd be accused of doing something wrong.
You're funny, Bob.
You're not allowed to think. My God.
Yeah, we don't need a vacuum chamber in order to have a vacuum.
No,
by
inside the
Kimo's
container, there is pressure and temperature. Outside, there is only temperature.
Where do we have high pressure in the atmosphere directly next to low pressure?
We don't.
Then why do you keep saying that?
That's your model.
Why do you keep saying it? We don't have it. That's
Your
not our
model-
model.
Your model says you have high pressure next to low pressure.
May I remind you, you're being recorded, Kimo.
Yes, your model says we've got high pressure down here.
You just said we
and
don't
low
have it.
pressure in space.
It's not right next to.
So
Wherever
you
that-
keep saying
wherever
we
those
don't have
are-
it, but you keep asking how we have it. Are you feeling okay, Kimo?
Wherever there is air,
Standing in
that
the
will still be
park.
higher pressure than space.
Have you got hypoxia, Chemo?
Hey.
What's going on, Jade?
But it's funny that he says that if you have a vacuum
Is that the
chamber and you
measles?
open, high pressure moves to low pressure. But then again, no, it's just high temperature moving to low pressure.
Yeah, unless you want the outside pressure to come from the container.
I
That you
think
can
guys
measure
keep-
the outside temperature,
you
the
guys-
pressure.
You're forgetting about the word sucking, okay? You guys are sucking. But
Oh, you suck.
the vacuum chamber is going to begin to suck when you like the
No,
atmosphere.
it
No.
doesn't.
No,
Oh.
I have to agree,
The
good sir.
atmosphere should be sucked. It should be sucked off the Earth's surface, right? With a
Vacuum.
No,
Vacuum
No.
chambers are not vacuum cleaners, David. Relax.
No,
The
no.
same thing happens. The same thing happens when you open the vacuum chamber.
Vacuum doesn't
Dallas.
suck.
It
Pressure
sucks in air.
pushes.
Right?
No, the pressure
can I-
pushes in. Jesus.
Yes, your pressure pushers. We already know your type.
If you try to think about water, for example, when you bring a container of air, for example, to below water, as you get lower and lower, deeper and deeper, the container starts to collapse on itself, right? That's not the air sucking the water. That's the water pulling the air, like, because of the pressure getting higher outside of the container. Right? You understand that, right? So same thing with vacuum. It's the analogy. It's the same.
Water is. If you go, we understand that you go up and it gets less and less and less and less and less and less, and then you believe that there's a point to where there is no more pressure, right?
So,
Oh,
okay,
my
Dallas
friend.
David. So, how does it get less and less and less, and then be sea level pressure again?
Because temperature is the force that keeps all the air on the Earth.
But there's less and less pressure up high because there's less and less atmosphere. So, how does
the
it get
gradient
hot
can only
again?
go as far as the gravitational field, which is not
Because it gets-
always forever in space. So you can't have gases, all the way to the moon unless the gravitational pull.
Microgravity, Kimo. Microgravity, my friend.
Are we in kindergarten? Should we start singing "Twinkle, Twinkle, Little Star"? How I
Well,
wonder.
there are
what you
gases
are.
all the way to the moon because our atmosphere extends all the way to the moon.
No, my friend. No, this was a measurement of something, and the flat earthers are using against our model. So there have been established it because the atmosphere of the Earth can be there, but it's nothing that is presumable to atmosphere to extend to the moon.
Yeah,
What's the point, Chemo?
as you get further from the surface, you can estimate the average distance between atmospheric molecules, for example. And it doesn't have to end at any point. It just gets larger and larger. So theoretically, at the moon, you have like molecules very, very far from each other, but that's
Where
kind of
aircraft
irrelevant.
can't fly is where the atmosphere ends.
Well, you know how airplanes work, right?
What with lift?
Yeah. How do they get a force upwards to counter their weight? From air pressure, right?
No, from
They create lower pressure above than it is below the wings. That's how they
got the air to push off.
They push off a water gas.
No, Dallas. Oh my gosh, dude. They don't push off a water gas. Oh my gosh. Oh my gosh, dude. Dude, have you ever heard of Bernoulli's principle? Okay. The surface of the top of the wing is longer in area or length from the front of the leading edge of the wing to the trailing edge. That's called the chord of the wing, from the leading edge to the trailing edge, right? The top of the wing is curved, the bottom of the wing is flat. Okay, so the relative airflow has to flow over evenly, so it has to cover a greater distance over the curved surface. Okay, so that air over the curved surface has to travel faster, okay, to meet its relative airflow at the trailing edge of the wing, which decreases the pressure above the wing, which doesn't lift the wing into the air. It literally decreases the static pressure and sucks the wing into the air. Or the Venturi effect. That's another one. Great. Okay.
What's with the accent, Joseph?
I don't know. I've got accent deviation syndrome or some shit. I just made that up. I'm not sure.
Like if you've got, it's just like there are no airplanes that fly above 20 miles up. Why is that? It's just like you, Jazzy. Your helicopter. The world record on a helicopter is only like 40,000 feet or something. It's not.
No, Dallas again. Okay, the world record for a helicopter landing, what we call in-ground effect.
Please stop the accent. Please.
I can't help it when I talk to
David, you say the helicopter can land on top of Everest?
Yes. I can try and find you the film for it. Didn't land on it. Obviously, there's not enough room, but they put a skid on the top of Everest for 2 minutes to get the record.
Right, but a helicopter, the world record's like 40,000 feet, the highest a helicopter's ever flown, right?
Pretty cool.
I don't know the highest. I only know the.
What would be the problem with this? What's the point? What's the point on that?
I don't know what John.
That's where the water gas starts to get thin at.
No, it gets thinner much before that. There, Dallas David. You do know that when you're in an airliner, right? And the air hose. Sorry. They give you the. They give you the.
He's going to be walking around and talking to people like this later today and catching himself, so don't worry about it.
You know how you walk around an airliner and they give you the.
Right, enough. Bacon. So
What?
I understand the model. Yes, this is the idea behind the model. But we're talking about in reality. Now, in order to have atmospheric pressure, you need a force. Yes?
Yeah.
What is that force?
Gravity.
Which gravity? Are we talking Einsteinian or Newtonian?
They both work. To create air pressure, they both work because their divergences in that scale are pretty much ignorable.
It's the same gravity, Kimo. It's expressed in different ways. It's the same stupid gravity.
If you want to use relativity to calculate air pressure, you would have an insanely higher amount of work and get basically the same result. Maybe with some more precise decimal numbers, but not that makes any difference at our day-to-day lives. So yeah, that's our answer.
So, what is the mechanics here in Newtonian gravity?
Sorry?
Kimo is the same gravity. What mechanics in the same thing that is behaving in the same manner? What mechanics is different?
Well, this is engineering. One is engineering, okay, and how can we describe the other? It's not engineering. Well, it's not engineering. But this.
Well, what was the point then?
We've got this Newtonian force, mechanical, that grabs hold of other objects and they pull.
What are you asking?
Heave ho, pull. Yes? Now,
What?
Einstein comes along and says, no, there is no pull.
No,
Nothing
he
here
doesn't
is
say there
pulling.
is no.
There is no pulling force here at all. Gravity is not a force. What actually is happening is, we've got this large mass bending the space, time, and fabric around, causing other objects to move. Not attract, no attraction. Okay? Because Einstein was saying it, let's say you've got the moon and the sun. No, the moon and the earth, sorry. Moon and the earth. And they are connected by whatever you say is gravity. So if we pull the earth away, what do you suppose would happen to the moon? What does it say in your model?
Well, we'll keep the velocity vector what it was. It would just be ejected out of the orbit.
No. See? Now, according to Einstein, there would be a delay.
According to Kimo,
I'm not. What I said, it's
No.
the same thing as I said, but with the delay. I just didn't know you weren't so specific.
There'd be a snapping effect with the fabric bending. So, if you pull the Earth away, there would be like a ripple.
Yeah, about 4 seconds, I guess.
no, but Kimo,
Now, if it was
you
Newtonian
seconds.
gravity
away
and you
first.
pulled the Earth away, okay, then the effects would be immediate. Because there is a pulling force, a connection, a pulling grip on one another. Now, again, with Einstein, that wouldn't happen.
Exactly, it would take about 4 seconds. Not just for the orbit of the moon to be affected, but if there is an observer on the moon, the person would still keep seeing the Earth for the same 4 seconds. Because light would travel, that's the travel of the effect of gravity is the same as we call the speed of the light in the vacuum. So not only the gravity would take 4 seconds to have an effect, but also the light.
Quickly depending on how much you disturb the fabric, would affect on how quickly or not quickly the effect would have on the moon.
Okay, Kimo, if you're going to be a complete arsehole, are you completely getting rid of the Earth, or is it getting collided into something? Or
yeah,
because it's a good question what he asked, because if you're going to apply other
think about these things, right?
Listen to what he was just saying.
It's a good question, because if you're going to collide Earth with another object, you have to apply the gravity of that object too. It's a very good question. Or if you want to take out the Earth in 1 millisecond, the effects are going to be different.
No. Like, let's take Cavendish for example.
Kimo.
Let's take Cavendish for example.
Hang on. The moon is already measurably moving away from Earth. So if you take away Earth straight away, just like it just fucking disappeared, then the moon's going to fuck off real quick.
No, this is why you can't compare it to magnetism. Because if we have attraction,
holy fuck,
mass attracted mass. If you move one mass, the effect on the other mass will be instant.
That's what I just said.
Probably that's what Newton thought, for example. Yeah, but under.
But if Einstein's correct, once we move the other mass, there should be a delay depending on how you disturb the other mass and move it out of the fabric.
Exactly.
Yeah, exactly. But you just said how it would be done. The Earth simply is no longer there after an instant, and that way, yeah, it would spread. The effect would spread in the speed of light.
Exactly. Or well, maybe not at the speed of light, but the Earth, which is we have the moon that's affected by us, and it's a quarter of our mass, and it is moving away.
Now, then.
So hang on. So you're saying that if the Earth if you could just vanish it, like you're the creator that created the flat Earth, just like, I'm a real basic bitch.
It's the creator created a real bitch.
No, hang on. Hang on, Dallas. I will rephrase that, my good sir. I will take that back. But what I'm saying is that if you guys think that the Earth's flat and it's a creator, then
it's
she's he or she is a real basic bitch, because everything has to be fake to make what you believe reality.
You're a basic bitch. You piece of shit.
I don't even think it was for the first time. So bacon. Now we can get back to premise. Which gravity now then?
I already answered that one.
What?
I already answered that one. Either of them are going to work the same.
Does gravity have a top and a bottom?
No, just where the.
I have no idea how to interpret that question.
No, it doesn't have a top and a bottom. So look, the pull here from the center of the mass of the Earth, bacon, is that what's happening, or is it dependent on space?
It might be neither of them.
Might be neither. Interesting. What it might be.
Yeah, I don't know. I'm not a theoretical physicist. That's actually what they're trying to do, to find another model, because they know.
Now we're thinking. You see, don't have any concrete evidence.
Yeah, but that's irrelevant. No. It's not that we. Well, there's a difference between finding a model that works to make predictions and finding a model that it's a true representation of reality. Even if you have a model that perfectly describes all the reality that we know, we still can't check whether or not that's the true representation of reality, or if it's just a compatible one, right?
Sure.
So scientists, many scientists don't even say they're trying to figure out the true nature of reality. They just want a model that works.
This is what we're talking about. An honest way of looking at the world. Okay, not sure. You have a good argument, but you've realised, well, I don't know which gravity I'm talking about. I understand they're fundamentally different. So for me to call out either would be a mistake, because obviously you can't demonstrate. So that's what we're talking about, bacon. A lot of these guys are so zealotry, dogmatic, not budge on their religious. Now, obviously, you don't want a religion. You want the facts, the and the numbers, which is a good way to look at the world. I mean, even flat earthers will tell you, we don't know what the sun is, we don't know what the moon is, we don't know what the stars are, no one's around the ball, no one's travelled all over the place. So, essentially, that's the starting point, and you build from that point to find out, what's going on. Welcome to not knowing Earth, not knowing what it is.
You're putting a whole...
I'm talking about difference of models that explain the fundamental nature of reality. Mapping the geometry of the Earth is way more simpler than that. It's not it's very hard to be so much agnostic about the shape of the Earth than it is about the true nature of reality. They're not comparable. That's not just because I don't claim to know the true nature of the laws of physics doesn't mean I have no idea how to map the surface of the Earth.
Well, the only question that comes into play with the sun is whether it's solid or not solid. We come from a paradigm currently, a way of thinking where we supposedly have mapped out all the elements, and whatever we find, sun or not, is supposed to be made of, one of these constituent parts, elements, or whatever. We tend not to accept, some statement about it being hydrogen gas or something solid of some sort, photons, whatever. That's the paradigm that we're working with, but we don't even necessarily. Size or whatever. That's
You cut off. You cut off.
Cut out there, Leopard.
Oh crap! But the main thing with the sun is I think it's about 3,000 miles away, based off a triangulation, about 32 miles in diameter, assuming it's a solidish object. Other possibilities is it's a light shining off of the curved glass dome with the solid beyond. Those are the only possibilities I find worth exploring currently.
Well, if you try to triangulate from the surface, as soon as you get like 3 or 4 points, they stop matching up.
Well, that's because triangulation is only good if you're local to the object. If you're trying to triangulate something like that's in your neighborhood, that's 50 feet above your neighborhood, your triangulation is only going to be good within a certain, mile radius of that point. Otherwise, the diffraction limit
isn't affected by distance.
Triangulation is only valuable until you can't see the object anymore. And with the sun circulating over the surface, you're going to get several triangulations to several places that are circulating over the surface.
We're all assuming we can see the sun, right? That's the thing we're trying to triangulate. But yeah, that's a long topic, and I have to go for now. But yeah. Well, see ya.
Go on and tell Lemon how you know. Oh, is he gone? Another one bites the dust. Another one bites the dust.
Hey.
Yeah. Gonna try and get
but you can triangulate under one location is a little specious because the object will dip down and merge with the surface due to the diffraction limit, making your triangulation increasingly off with more and more distance. So a lot of these assumptions are bunk anyway.
Well, everything you just said is wrong.
Oh yeah.
Everything? What's wrong about it?
The diffraction limit, blah blah blah, all that shit. Wrong.
The diffraction limit means that two light sources that are separated, like the ceiling and the floor, will eventually merge into one unresolvable object, the horizon. So the sun will eventually merge into the surface by that logic.
Is that how that works when you actually look at ships on the horizon? It doesn't work that way.
In what way does it work then?
Well, you zoom in and you still see them beyond the horizon.
There's still a limit to these optics. They can't zoom forever. They're still diffraction limited and can only zoom so far. You're acting like the camera can just bring back anything into relief. That's not necessarily the case.
I'm not acting like that. You're the one that said it.
So basically, the ceiling is merging with the floor over the flat surface, and your optic can bring back some, but not all of the image. That's it.
So what explains the other half that you can't bring back? What explains that?
You make angles from the level of the eyes up and down. From the level of the eyes up, you get a tighter angle if you don't go up too far from the level of the eyes, and a wider angle if you go further up and away from the level of the eyes. This means that you're going to have more smushing toward the level of the eyes and less smushing away from the level of the eyes. The part of the image that is closer to the level of the eyes has smushed a whole lot more, cutting off the object bottom up. That's why you can see part of the sun, but not all of it when it starts to vanish beyond the diffraction-limited horizon zone. You get a wider angle up to that point and a more smushed angle up toward the level of the eyes.
Except you can actually zoom in on the sun far away on the horizon and see that it's not doing that.
And it doesn't change angular
Still
size
diffraction
too.
limited. It's just the diffraction limit and being too close to the surface. If you want to see the object disappear down to a pinprick, like you're implying, you need to levitate up into the air and be at the same elevation as the sun. Then, as it goes away parallel to the level of the eyes, it can disappear down to a pinprick finally. But if you're too close to the surface early...
It doesn't do it from 30,000, 40,000 feet either. It doesn't change angular size. I'm sorry to break that to you.
It changes size with a filter or without one.
No, it doesn't.
They don't want to admit the sun is local and close.
More than likely it is.
Hang on. That's the thing. If the sun is local and close, then the sun's going to have to be doing more than fucking 15 degrees an hour, isn't it? The moon's going to have to rotate 20. It's going to have to rotate in 20 instead of 27 days for a 360-degree rotation. It's going to have to rotate every 24 hours. The same as the sun, every 15 degrees. So there's...
you think it's 93 million miles
we
away?
Can see the moon tidally locked. If everything's close and local, fucking check your shit.
Listen to me. You think it's 93 million miles away, and yet you have not proved that.
I can't prove that.
How would we prove
I don't have a $93 million,
no
93 million meter kilometer fucking
We're
measuring.
just saying it's close and local.
Well, how would we prove that?
No.
How would we prove that to you?
Lasers, monkey, lasers. We fire long-range lasers.
You guys have done that it's close and local. No, you haven't. And secondly, you can't, because if it is close and local, then it has to be going a hell of a lot faster around the Earth than it is.
Well, we have some lasers, and it is as far as science says it is. Yeah.
And the moon, if the moon's tidally locked, we always see the same face. The moon's a sphere. If you're
No, we've never seen the dark side of the moon, Jazza.
Exactly, and we can observe the moon as a sphere because it has shadows. Whether it's a full moon, a half moon, it doesn't matter what the fuck the moon is. We can observe that it has shadows. So it's a sphere. Okay, so if the moon's going around the flat Earth and providing the same face, tidally locked to the flat Earth, then the southern hemisphere should see the dark side of it.
Those craters were sucked in from the inside? Why do you think it was created from the outside?
Oh my God! Now you're just coming up with stories, just like the flat Earth is.
About them being
No. The funny thing is that it's not a story. It's that we were taught. We weren't told. You were told the Earth flat.
Yeah.
Like 200 proofs. Eric Dumbays.
It's not from the inside, Jazza.
But you were taught something that doesn't match what your senses see, so there's going to be inherent cognitive dissonance there, where your eyes say flat, but the NASA, deceivers say round.
But Lemonbird, at the same time, I know for a fact that your senses in the wrong place and the wrong time, and you will find this one day in your life, many times actually, your senses in the wrong place and the wrong time can have you killed. Because you
They're
believe.
trustworthy enough.
What?
They're trustworthy enough.
Jazza,
No, they're not.
Jazza, are you going to drink for like ever?
Is that your defense?
Annoying. Drunken behaviour. If you were sober, you would see the Earth is flat, not a globe.
Dumb fuckery is more than annoying. It's not only annoying, it's fucking entertaining.
And the reason why they told us this model is because it helps put you on the track toward atheism and materialism and moral relativism. It has a psychological component that they just love, despite the fact that it doesn't even match reality. So you need to peer through the veil there, Jazza.
Okay, Lemonbird.
See?
I'm sorry.
Jazza, this is because you're drunk. If you weren't, and you would take this very seriously.
Sorry, I was doing it again.
Lemonbird.
Lemonbird.
You have to trust your senses to make an observation. Just to question.
No, you don't. You don't.
So you don't have to
Hold on, let's
trust
put
your
Jazza down.
trust your
Hold on, Paul.
senses to do an observation. That's interesting.
Got more
Go
expert.
onto a roof. Here's a great example. Go onto a roof on your house, and you're cleaning the leaves out of the gutter. Right? Now stand with your toes right on the gutter and look at the ground. And if you can tell me that you don't feel like you're falling forward onto the ground, I'll give you $1 million.
Oh, I feel like I'm falling forward. Fuck that.